Oh, I didn't see you there. Here's an example of some optimization of a two-dimensional sort that I'm going to be doing with my pre-calculus students. And here's an example that if you go to my web page, you can actually find an answer key for. And here's an explanation of that question. Suppose that someone wants to create a rectangular enclosure that has 7 parallel fences in the interior of the enclosure, and they only have 540 feet of fencing to create the entire design. So they want to build it so that you've got 8 different separated pens inside the giant fence. So you got 1, 2, 3, 4, 5, 6, 7 fences in the interior of that rectangle. And the way that the procedure that I talk about in terms of working this out, I believe is done in 7 steps. And that first step is to draw a picture. This picture is not good enough. Well, one reason is because it's kind of a lopsided rectangle, but a more important reason is not labeled. So what you want to do is you want to label that. You can use X and Y or L and W to represent the picture. The second step is to dig into what is the constraint. A constraint is something that holds us back, like a restraint, like a seatbelt is a restraining device. A constraint here in this question is, I didn't add it on here, is that you only have 540 feet of fencing available. So to build this, we would say that, well, to build this design, we would need 2 L's and we would need 9 W's to come up with this configuration. So 2 L's plus the 9 W's would equal 540 feet. The third step that I have is to improve the equation above. So an improved version of this would look like with one variable on one side. So you could subtract 9W from both sides. You get 2L equals 540, take away 9W, and then divide by 2. And now we've got a more useful equation that we can stow away just for the time being. The next step is an important step. It's a very, very small step, is to list the objective equation. What is the equation we're trying to zero in on? What are we trying to maximize? I call this one the objective equation. It's our main objective, is to figure out what the maximum area would be. So you need to make an equation that represents what we're trying to get. We're trying to get the most area. The area of this picture by formula would just be length times width. Once you have those two equations here, we're going to merge them together with the substitution process to create an improved objective equation. So to improve this, we would want to get rid of one of the letters, so that all we had would be one letter. So the improved version of this would be area equals 270 take away 4.5 times W. And that's pretty decent. We can make a better improvement on it by changing it into 270W minus 4.5W squared. Why would I want to make that move? Well, the reason I would want to make that move is because of the next step. And the next step is to use calculus. Is to take the derivative of the objective equation and set it equal to 0. So the reason why we wanted to rewrite that equation, the reason why we wanted it with just one variable, is so we could find the derivative of this guy right here, which is 270 minus 9W. Set it equal to 0, and you're on your way. Add 9W to both sides. divide by 9, and you find out that the width is equal to 30. The last step, the 7th step, is to plug in all the information and develop the final answer. So we know that the width has to be 30. How about the length? Well, in step 3, we've got a very convenient formula listed to find the length based on the width. If we know the width is 30, we plug that in, and you can find out that the length is equal to, is it 135? I think it might be. So this might be the most area we can get. I'm back. What did you think I left you? Here's the final answer then. I was just double checking my arithmetic. I need some room to write the final answer. Looks like up here there'll be some spot, a good spot for it. The maximum area then would be length times width. We got both the length and the width. So 135 times 30 tells me the most area we can get out of this would be 4,050 square feet. And I'll try to pass on an example with 3 dimensions tomorrow, but that's just a general walk through the steps.